Have you ever pondered the mysteries of the universe? What sparked its existence, and how did we come to be? Imagine a time before time, a point of singularity where it all began, the Big Bang. The universe in all its vastness and complexity unfurled from that one cataclysmic event. A cosmic ballet of galaxies, stars and planets, each with their own tale to tell in the grand narrative of existence. Embark on this journey through time and space as we unravel the story of the universe. Our story begins with a colossal explosion, a phenomenon we now call the Big Bang. Picture a moment of extreme heat and density, so intense that it's beyond human comprehension. This solitary, infinitesimal point, teeming with raw, untamed energy, suddenly burst forth, setting the stage for the grand cosmic theater we now inhabit. This was not just an explosion of matter, but of space and time themselves. In the Big Bang's wake, the universe started to expand, a process that continues to this day. But what is the Big Bang Theory, you might ask? It's a scientific explanation about how our universe began, based on a wealth of observational evidence, including the cosmic microwave background radiation and the large-scale structure of the cosmos. In the immediate aftermath of the Big Bang, the universe was a hot, dense soup of particles, a state of matter known as a quark-gluon plasma. As the universe cooled, these particles began to combine, forming the first atoms, primarily hydrogen and helium. These atoms, the building blocks of everything we see around us, were the first to populate the expanding universe. However, the universe at this point was far from the star-studded expanse we know today. It was a dark, almost featureless ocean of gas, devoid of stars or galaxies. This period, known as the Cosmic Dark Ages, lasted for hundreds of millions of years. Yet, within this primordial darkness, the seeds for the future structure of the universe were being sown. Tiny fluctuations in the distribution of matter left over from the Big Bang began to grow under the influence of gravity. These ripples in the cosmic sea would eventually grow into the galaxies, stars and planets that fill our universe today. From an explosion of unimaginable energy, the universe as we know it began to take shape. The Big Bang, the very birth of space and time, set the course for everything that would come after. From the first atoms to the galaxies we observe today, all have their roots in this extraordinary event. As the universe cooled and expanded, matter began to clump together, forming the first galaxies. This process, known as galaxy formation, is a magnificent cosmic ballet, choreographed by the forces of gravity. Picture the early universe as an enormous blank canvas, sprinkled with minuscule particles of matter. As the universe expanded, these particles, drawn to each other by gravity, began to coalesce into larger and larger structures. Over billions of years, these structures evolved into galaxies, each one a unique masterpiece of cosmic artistry. Galaxies are not just collections of stars, but complex systems with diverse structures. Some galaxies, like our own Milky Way, are spiral galaxies with elegant winding arms of stars and gas. Others, known as elliptical galaxies, are more uniform in shape, appearing as vast glowing spheres. And then there are irregular galaxies, the rule breakers of the cosmos with no defined shape and a chaotic beauty all their own. Speaking of the Milky Way, it's quite a sight, isn't it? This majestic spiral galaxy, teeming with billions of stars, is our cosmic home. Picture the Milky Way as a bustling city of stars with our sun and Earth residing in one of its quieter suburbs. The Milky Way, like all galaxies, is not just a collection of stars but a cosmic ecosystem with gas, dust, dark matter and possibly other forms of life. The formation of galaxies is not just a distant cosmic event but a process that continues to this day. As we speak, new galaxies are being born in the farthest reaches of the universe, a testament to the ever-changing nature of the cosmos. So, galaxies, these vast celestial cities, are not just beautiful to look at, but they are also the birthplaces of stars and planets. They are the cosmic cradles where matter comes together, under the guidance of gravity, to create complex structures like stars and planets. In these galaxies, the stage was set for the birth of stars and planets. In the vast cosmic nurseries of galaxies, stars and planets were born. This is a process that has been unfolding for billions of years, and it all begins in the quiet, dense pockets of interstellar clouds. These clouds, composed of gas and dust, are the breeding grounds for stars. Under the influence of gravity, these clouds start to collapse inward, forming a dense core. This core continues to accumulate matter, growing hotter and denser until nuclear fusion ignites at its heart. In this fiery furnace, hydrogen atoms are compressed and fused together to form helium, releasing a tremendous amount of energy in the process. This energy pushes outward, counteracting the inward pull of gravity, and thus, a star is born. Stars are not eternal, however. They have a life cycle, much like living organisms on Earth. They are born, they live, and eventually they die. The life cycle of a star depends on its mass. Smaller stars like our Sun live for billions of years, while massive stars burn out in a few million years. When stars exhaust their nuclear fuel, they go out in a spectacular fashion, often resulting in a supernova, a cosmic explosion that can outshine an entire galaxy. Now what about planets? Planets, including our Earth, are formed from the leftover material that didn't make it into the star. This material, orbiting the newborn star, slowly starts to clump together under gravity, forming planetesimals. These planetesimals collide and merge, growing bigger and bigger, until they become planets. The birth of stars and planets is a complex and beautiful dance of physics, a testament to the incredible power and creativity of the universe. It's a process that has given rise to countless stars and planets, including our own solar system. And in one particular corner of the universe, on a planet orbiting a medium-sized star, life as we know it has found a way to exist. Among billions of celestial bodies, our home planet Earth found its place. In one small corner of the universe on a planet called Earth, life emerged. Amidst the vast expanse of space, in an unassuming corner of the Milky Way, our home planet spun into existence, brimming with the potential for life. Millions upon millions of years ago, Earth was just a fiery sphere of rock and gases. But then, as it cooled, water vapor condensed and formed vast oceans, creating the perfect conditions for life. This transformation was no mere happenstance. It was a delicate dance, a precise equilibrium of cosmic factors. Just the right distance from the sun, Earth found itself in the Goldilocks zone. Not too hot, not too cold, but just right for liquid water to exist. The sun's warmth, the planet's magnetic field, the chemical richness of the soil and water, all these factors came together in a remarkable confluence, setting the stage for the miracle of life. The first life forms were simple, single-celled organisms, basking in the primordial soup of Earth's early oceans. Through time and the relentless process of evolution, these humble beginnings gave rise to a dazzling array of complexity and diversity. From the smallest microbe to the largest whale, from the quietest moss to the tallest redwood tree, the Earth teems with life in all its varied forms. And then, there's us, humans. We are the product of billions of years of cosmic history, the end result of a process that started with a big bang and a cloud of cosmic dust. We are the universe experiencing itself, pondering its own existence. From the simplest organisms to intelligent life, Earth is a testament to the universe's capacity for life. It's a humbling thought, isn't it? We are but a small part of a grand cosmic story, a tiny chapter in the universe's ongoing tale of creation and discovery. But oh, what a chapter we are. As we look to the future, we can't help but wonder, what lies ahead for our universe? Theories abound, each more intriguing than the last. Some scientists propose the Big Freeze, a scenario in which the universe expands indefinitely. Over trillions of years, stars burn out, galaxies drift apart, and eventually, all matter decays into subatomic particles. The universe, in essence, becomes a cold, dark, and desolate place. On the other hand, there's the Big Crunch theory. This is the exact opposite of the Big Freeze. Here, the gravitational pull of all the matter in the universe causes it to stop expanding and start contracting. Ultimately, everything collapses into a single point, a mirror image of the Big Bang, which could potentially trigger another universe's birth. Yet these theories are not definitive. They change and evolve as we continue to explore and understand the cosmos. Every new space mission, every deep dive into cosmic phenomena, brings us a step closer to unraveling the mysteries of the universe. The importance of ongoing space research and exploration cannot be overstated. It's not just about satisfying our curiosity. It's about understanding where we come from, where we're going, and perhaps finding our place in this vast cosmic tapestry. While the future of the universe is unknown, one thing is certain: its story is far from over.